Hi students, welcome to this class. Till now we completed 4 units of engineering drawing syllabus. In the last class we discussed the projections of solids 1 and 2, which includes prisms, pyramids, cone and cylinder. This is the last unit, unit 5 in the engineering drawing syllabus, which involves 2 parts. First part is conversion of isometric views into orthographic views. And coming to the second part is vice versa, that is conversion of orthographic views into isometric views. So first of all, what is an isometric view? What is an orthographic view? I already discussed in previous chapters orthographic views. What is meant by orthographic views? So till now we drawn the projection of from projection points to projection of solids. The projections are all the projections are orthographic projections. Orthographic means perpendicular to the reference plane. The views which are projected onto the reference plane, while projecting the views onto the reference plane, the lines which are drawn from the contour of the object, which are parallel to with each other and also perpendicular to the reference plane on which we are projecting the object. So the projection lines which are perpendicular to the reference plane on which we are projecting. So that's why we are the projections or views are called orthographic projections or orthographic views. Coming to the isometric view, what is an isometric view? Isometric view is a that is a 3-dimensional view which having 3 dimensions: length, width and height. It is a 3-dimensional view. From the 3-dimensional diagram, 3-dimensional object, we have to draw the orthographic views. Orthographic views are 2-dimensional views which having only length and width, or length and height, or width and height. So we have we have to draw the 3 views for the given isometric view or isometric diagram. 3 views are front view, which is projected onto the vertical plane; top view, that must be projected onto the horizontal plane; and side view. Side view is projected onto the profile plane. So side view having 2 side views are there: left side view and right side view. When we looking the object from the right side of the object, then the views which is projected onto the profile plane is called the right side view. When we looking from the left side of the object, the view which is projected onto the profile plane is called the left side view in the first quadrant. Clear? So if it is in third quadrant, left side, the right side view is on the left side of the front view. Left side view is also left side of the front view. Right side view is right side of the front view, left side view on the left side of the front view. But in first angle projection, that is when the object is in first quadrant, the front view or top view is always below the front view. Till now we drawn the front view is above XY line, top view is below XY line. So top view is always below the front view, and the side view extra we are going to draw the side views here. Left side view must be drawn on the right side of the front view, and the right side view must be drawn on the left side of the front view. That is first angle projection. That is called the first angle projections. Let us go for the diagrams or theory. This is the orthographic projections. It is a technical drawing in which different views of an object are projected on different reference planes, observing perpendicular to the reference planes, that is the respective reference planes. Whenever you are observing the perpendicular to the respective reference planes, the views are orthographic views. Okay. Different reference planes already we studied in the previous chapter, that is a horizontal plane, HP, vertical plane, VP, and extra in this chapter we are going to study about the side or profile plane, PP, profile plane. On this profile plane, we have to project the side views, either right side view or left side view. Clear? So different views are front view, FV, top view, it is represented by TV, and side view, SV. If it is right side view, RSV. If it is a left side view, you have to represent that side view as LSV. Clear? So FV is view projected onto the vertical plane. Front view is always projected onto the vertical plane when looking from the front side of the object. Okay. Top view is the view projected onto HP. So top view is always projected onto the horizontal plane, which is below XY line when we're looking from the top side of the object. So SV is a view projected onto the profile plane. Side view, which is projected onto the profile plane. Which is side view is always adjacent to that. That is besides on both sides of the front view. If it is right side view, left side of the front view. If it is left side view, right side of the front view. Clear? The side view is observing when the object is from the side of the object, either left side or right side of the object. These are the planes, reference planes on which the views are projected. These views, front view, side, top view, and side. Clear? Let us look at one example here. First angle projection. We are following in this first angle projection method. In this method, the object is assumed to be situated in first quadrant, means above HP in front of VP. So first quadrant lo unte that object is represented with respect to the planes above horizontal plane in front of vertical plane. Clear? So object is in between observer and plane. In this first quadrant system, object it is in between observer and plane. This is the vertical plane. Blue color is the vertical plane on the drawing sheet. It is a plane of paper. It is an XY above. Front view is always above XY. That front view is projected onto the vertical plane. And top view, which is below XY. If it is in first quadrant, the top view is below XY. The top view is projected onto the horizontal plane when looking from the top side. And the side view, this is the side view. Yellow color is the profile plane. That left side view, that is right side of the front view. Left side view is always right side of the front view. If it is right side view, the right side view must be on the left side of the front view in this side. Clear? So it is the left side on the right side of the front view. That left side view is projected onto the profile plane, which is also above XY line, which is besides the front view. Okay? Like this, you have to draw 3 views for every object in this chapter. Clear? Actual pattern of the planes and views in first angle method of projections like this. Let us take one object. This is the object, a rectangular block. Okay. This in rectangular block, this blue color is the one of the view. Yellow color is the one of the view. That is the left side view. And top view is the green color. Okay. When looking from this side, the object observer is like looking from this side. This is the shape, that is a rectangular shape, which will be visible surface. This surface is visible. Clear? From the side view, this yellow color surface is visible. From the top view, this green color surface is visible. So for this rectangular block object, this is the for front view. For front view, FV, we have to observe from this side. This is the for top view. For top view, we have to observe from this side. From side view. So for side view, you have to observe the object from this side. Clear? When we looking from this object from this side, this surface, blue color surface is visible. When looking this object from the top side, that is of our top view, the green color surface is visible surface, and remaining all coincide with this. And for side view, we have to view this object from this side. So yellow color surface is visible, not other 2 surfaces. Clear? So like this, you have to draw the 3 views for this object. Let us go for this. When looking from the object from this side, you have to project these projection lines from the contour of the object. For every corner of the object, you have to draw the projection lines onto the vertical plane. This is the vertical plane. Clear? So vertical plane it is. Onto the vertical plane, the object is projected like this from every contour of the object. So the visible surface is blue surface. Looks like a rectangle. Clear? This is the front view of this object. Clear? Let us go for the another. It is a front view. Let us go for the projection. We draw the projection lines from the top side. These are the projection lines which are parallel to with each other and perpendicular to the plane, which is projected onto the horizontal plane. This plane is horizontal plane, HP. Clear? Horizontal plane on which the object is projected like this. So this surface is visible surface, green surface is visible surface that will be drawn on the horizontal plane. This is the top view of the object. That is top view of the object. Clear? Next, coming to the side view. Which type of side view can be drawn for this object? When observer is looking from this is the first side view in this direction, it represents the left side view, because when looking from this object, observer at this place for the front view, this side is on the left side of this observer. Left side of the observer. So when looking the object in the left side of the observer, the formation of view is left side view. So that left side view is on the right side of the front view. In this direction, you have to draw the side view. That is the left side view. That left side view are projected onto the profile plane. This is the yellow color is the profile plane or side plane on which the side view is projected. This is the side view, left side view. This is the profile plane PP, and this is the side view. Clear? So by observing these three diagrams, front view below is the top view, front view side is the side view. Front view adjacent to the front view is side view. Clear? You have to draw like this in this position. So front view is the front view on vertical plane, top view on horizontal plane, side view on profile plane. So for this object, you have to draw like this. These are the orthographic views. Front view, top view, and side view are the orthographic views. This block is represented isometric view. This is isometric diagram. This block is object is isometric diagram. We are converting this isometric view into orthographic views. Three orthographic views. These are the orthographic views which will be formed by drawing the projectors from the object which are perpendicular to the planes respect to reference planes. These projectors are perpendicular to the vertical plane. These projectors are perpendicular to the horizontal plane, and these projectors are perpendicular to the profile plane. These perpendicular projectors stretch ఒకటి ఈ వ్యూస్ ని ఆర్థోగ్రాఫిక్ వ్యూస్ అంటారు. ఆర్థో మీన్స్ 90 degrees. Clear? Ortho means perpendicular. So perpendicular projectors onto the planes are called the orthographic views. We are converting this object into three views. Clear? This is the three-dimensional diagram which having the length, width, and height. But orthographic views having the two dimensions. These are the two-dimension diagrams. It's having the length and height in the front view, width and height in the side view, length and width in the top view. Okay? Top view lo manaku kanapadedi enti length and width. Front view lo kanapadedi enti length and depth or width. Side view lo depth or width and height. Clear? This is the one of the example. I hope you understand this diagram. If you understand this diagram, we can go for a complicated diagrams. This is another diagram, L block. In this L block, a green color represents the front view, and blue color arrow represents the side view, and top view is the red color arrow mark. When looking from this side, object observer is at this place. The front view surface is when looking from this side, observer, the front view, the visible surface is this one. Clear? Visible surface is this one, L shape. So L shape is the front view. Clear? On below that front view, you have to draw the top view. Always top view is below the front view. Clear? If it is the length, this is the length. This is the width. This is the length. This is the width. And height is, this one is the height. This one is the height, length of the height of the diagram. So when looking from the front side of the object to draw the front view, visible dimensions are length and height. This is the length and height. So for the top view, when looking from the top side, the visible dimensions are, this is the width, this is the width, and length. Clear? From this one is the length. This is the length and width. So length is common for front view and top view. So that's why top view is always below the front view. The front view ki top view always below ne draw cheyali. That is the condition in the orthographic projections. Coming to the side view, in the side view, the visible dimensions are width and height. Width and height. So this is the width and height. Height is the common dimension for the side view and front view. So that's why the side view is always adjacent to the front view, either this side or this side. For this diagram, when we observe the green color is the front, if the green color arrow mark represents the front view, this is the side view, it becomes side view. What type of side view it becomes? The arrow mark, that is the blue arrow mark on the right side of the green arrow mark. Okay, that's why here the right side view is possible. We cannot look the diagram from this side. So we can look the diagram from this side. The right side view is only the possible for this diagram. So that's why the right side view is always left side of the front view. If front view ki left side lo draw chesta. Clear? So in the top view, from the top view, the visible surfaces are from the top view. These are the visible surface. This one is the visible surface, and this one is the visible surface. When looking from the top side, this line is coincide with this side. This line. When looking from the top side, these two are the coincide with each other, and this is the visible surface. This is the visible surface. So here, this is the visible surface, and this is the visible surface. Here. And from the side view, which surface are visible? This is the visible surface from the side view, and this surface is visible surface. Clear? So this line will coincide with this line when looking from the side view. These are the same on the same surface. These two lines are on the same surface, horizontal surface. That's why these are coincide with each other from side view. So this surface and this surface is visible surface. I'm drawing from this point to this point height, and this point will coincide with this point, and from this it will be extended to the height like this. So the point, this point comes to front side when looking from the side view. So like this, you have to draw the surface which is visible at this place. So this is the surface. These are the two surfaces are visible from the right side. Clear? That is called the right side view. So this is the three views, front view, top view, and right side view for this isometric view. This is called the isometric diagram or isometric view, which having the three dimensions: length, height, and width. Why it is taken as length? When looking from this side, green is the, if the green arrow represents the front view, from the front view, horizontal to the observer, that is horizontal to the observer is called the length, and height is this much, and width is in the direction of viewing of observer is the width. When looking from this, in the direction of viewing, the dimension is called the width. Horizontal on the plane of horizontal to the observer is called the length, and height is like this. Clear? This is the second example. Let us go for the third example. This is the another block, three-dimensional block. This is the front view. For front view, this is the front view, side view, and top view. Whenever the arrow mark represents for front view, the other two sides are, one is the top view, another side is the front view. Okay? If it is front view from this side, the visible surfaces are pink surfaces. Clear? So pink surfaces, you have to draw the pink surfaces as front view like this. Clear? This one is the visible surface, pink surface. This pink surface is also visible. This is the front view, which is projected onto the vertical plane. This is the front view. Okay. And coming to the top view, when looking from the top side of the diagram, the green surfaces are visible. Okay. Green surfaces only the visible surfaces, which is projected onto the horizontal plane like this. These green surfaces are visible in between lines, which is divided by the lines divide the surfaces. This is the L-shaped surface, and this is the rectangle. This is the rectangle surface, which will be drawn onto the horizontal plane, which represents top view of this object. Clear? So coming to the side view, for side view, the blue surfaces are visible surfaces. So this is the L shape here drawn, and this rectangular, two rectangular surfaces are visible. Clear? This rectangular surface is drawn at this place, and this rectangular surface is above this rectangular surface. This is the side view. Which type of side view that is? When the observer is looking from this for the front view, this side becomes left side view. So this side view is called the left side view. The left side view is always the right side of the front view. You have to draw on the plane of paper. The left side view is always the right side of the front view. Top view is always below the front view. Clear? I hope you are understanding this diagram. This is isometric. We are converting this isometric by viewing from different sides. We will get the different views: front view, top view, side view. Clear? Let us go for the actual diagram. This is available in the this diagram is available in the question bank, which will be given to you. Draw the front view, top view, and side view for the following isometric diagram. This is the actual given diagram. Exam lo ila istaru. Dini chustu meeru aa 3 views draw cheyali. So ikkada arrow mark representation chudandi. This arrow marks direction is the front view direction. Clear? This is X represents, arrow mark represents is front view direction. If it is front view, we can draw which type of side view for this diagram. This is the side view. When we looking the diagram from this side, the side view will be formed. So in which direction the side view is there for the front view? It is in left direction. When observer is at this place, for the front view, this direction is the left side of the observer. So we can draw this for this diagram left side view. So left side view must be right side of the front view. Clear? So before going to start this diagram to convert into orthographic views, we have to know the length, width, and height of this total diagram. Clear? What is the length? Length means when we are observing from this side, the parallel to the observer is called the length. So here the length is 75. Clear? You have to take this 75 as length of the diagram. Clear? So what is the width or depth of the diagram? When the observer from looking from this side, in the view direction, in the sight of rays direction, the dimension is width. This is 50, the width or depth of the diagram. Clear? What is the height of the diagram? Here represents 12. This bottom rectangular block is having the height 12, and the remaining height is 25 given here. So from the top side of the rectangular block is 25, and remaining height, the bottom rectangular block is 12. That is, from this to this is a thickness is 12. This thickness is 12. This point coincides with this point when looking from the front side. The height is 25. So total height is 25 and 12. Total 37 is the height of the diagram. Clear? Total diagram height is 37. Maximum height is 37. Maximum length is 75. Maximum width is 50. In this, when we're looking from the front side, this is a front view. Which surfaces are visible first? So I am hatching the visible surfaces from the front side. This is the visible surface, and this is the visible surface from the front side, and this is the visible surface. Here, these three surfaces are visible from the front side. Along with these three surfaces, this surface is also visible surface from the front side. Clear? So you have to draw the front view using these four areas. Visible surfaces 4 are there. You have to draw in the front view. These 4 areas are 4 surfaces. Clear? Next, from the side view, if you're looking from this side, which surfaces are visible? This surface is visible from the side view. And this is the slant surface is also visible. This is the slant surface is also visible surface. These two surfaces are visible. Another in this direction, another surface is there, this surface, which is in between these two surfaces, but it is invisible surface. Okay, when we are looking from this side, this is the invisible, but it is in the direction of side view only. So you have to draw the dotted line when the surface is invisible. Okay, dotted line ఎప్పుడు డ్రా చేస్తాం, ఒక సర్ఫేస్ ఇన్విజిబుల్ అయినప్పుడు ఆ సర్ఫేస్ యొక్క కార్నర్స్ కానీ ఎడ్జెస్ కానీ డాటెడ్ లైన్స్ గా డ్రా చేస్తాం. క్లియర్? సో ఈ ఎడ్జ్ అనేది దీంతో కోయిన్సైడ్ అవుతుంది. ఇక్కడ ఒక ఎడ్జ్ ఉంది చూడండి, ఈ ఎడ్జ్ అనేది ఇక్కడ డాటెడ్ లైన్ గా వస్తుంది. ఇక్కడ డాటెడ్ లైన్ డ్రా చేయాల్సి ఉంటుంది. These two surfaces are visible surfaces from the side view. Let us go for the top view. So top view is when we looking from the top side. This is the rectangular block is the visible surface, and this total surface, this surface is visible, which is towards the top side. Clear? This surface is visible surface. Like this, you have to divide the surfaces into different parts in different views. The total diagram is looking like this. Here, this is the isometric view. You have to convert this isometric view into orthographic views, two-dimensional diagrams. Draw the front view, side view, and top view. So from the front side, this is a red hatching over the visible surfaces, and from side view, this green hatching are the visible surfaces, and from the top view, this is the violet colored hatches or visible surfaces. Clear? Let us go for the, first of all, you have to locate the length, width, height. What is the length of the diagram? 75. L equal to 75. Width is 50 mm. And height is, how much height it is? From this point to this point is 12. Remaining height is 25. The total height of the diagram is 37. Clear? And you have to draw the front view, top view, side view. In the box methods, you have to draw the boxes first with these dimensions. So front view box must be represents when looking from this side. The front view box, in the front view, the visible dimensions are length and height. Length and height are visible dimensions from the front view. And from the side view, when looking from this side, the visible dimensions are width and height. Width and height, top view. Sorry, it is not length and width. The top view. Top view is the from when looking from this this diagram from the top view. The visible dimensions are length and width. Length and width. And the side view, from the side view, it is the left side view. Visible dimensions are width and height. So these are the three views which are related to the diagram. Three views. The three views which will be dimensions. Which dimensions are visible in three views means front view length and height, top view is length and width. Length is common dimension in these two, and third one left side view is the width and height. In this, height is common, and this is width is common from the top view and left side. So front view first draw cheyali, tarvata top view draw cheyali, tarvata left side views, either right side view or right side view, how to draw then lastly. Clear? Let us go for the diagram. First, draw the box, front view box. Front view having the dimensions length and height. How much length? Length is 75 mm. Draw the 75 mm. And height is 37. So 37. With this 75 and 37, construct a rectangular box. Within this rectangular box, we have to draw the front view of this diagram. Okay. Next, construct the side view. This is the side view box. Side view having the dimensions width and height. So width is this much. How much width? 50 mm. Draw the 50 mm length, and height is 37, which is equal to the height of the front view box. Okay. With this width and height, you have to construct another box which is adjacent to the front view box. It is the left side view kabatti meeru ee box ki front view box ki right side lo left side view box draw cheskovali. It is a box method. And next, draw the top view. If it is front view, you have to draw the top view below the front view. So top view box, top view represents length and width. So how much length? 75. 75 length, which is equal to the length of the front view box. And height is 37. Oh, sorry. Top view is width is 50. So draw the 50 width with the 75 and 50. Draw another box which is below the front view. Length is common for these two boxes. Height is common for these two boxes. Okay. This is a side view box, front view box, top view box. Clear? Actually, ఇప్పటివరకు మనం డ్రా చేసింది అంటే ఒక XY లైన్ డ్రా చేస్తున్నాం. ఇక్కడ ఈ XY లైన్ కి అబోవ్ ఫ్రంట్ వ్యూ, బిలో టాప్ వ్యూ. ఓకే. Another view is the side view is there. Side view is always adjacent to the front view. Okay, ఈ front view side view అనేది adjacent గా ఉంటుంది. Left side view అయితే ఎటు డ్రా చేయాలి, అదే right side view అయితే left side లో వచ్చేస్తుంది. Okay, here in this, from this onwards you did not draw xy line. xy line draw చేయాల్సిన అవసరం లేదు ఇక్కడ. ఓకేనా, xy line, no need to draw the xy line. You have to construct 3 boxes like this. అర్థమవుతుందా? ఇప్పటివరకు మనం xy line డ్రా చేసి xy line above front view, xy line below top view if it is in first quadrant, ఇవి రెండు డ్రా చేశాం. క్లియర్? సో ఇప్పుడు xy line డ్రా చేయకుండా కొంత గ్యాప్ వదిలేసి 2 బాక్సెస్ డ్రా చేయండి. ఫ్రంట్ వ్యూ బాక్స్, టాప్ వ్యూ బాక్స్. ఈ ఫ్రంట్ వ్యూ బాక్స్ అడ్జసెంట్ నే సైడ్ వ్యూ బాక్స్ డ్రా చేసేస్తుంది. ఈ బాక్స్ డైమెన్షన్స్ ఇక్కడ రిప్రజెంట్ చేశాను. క్లియర్? సో ఆఫ్టర్ డ్రాయింగ్ ద బాక్సెస్, coming to the visible surface in the front view. I already explained the visible surfaces are, this is the visible surface from the front view. You have to start with the front view. This is the front view surfaces, visible surface. Starting from one of the corner, you have to draw a line, a horizontal line. This line is visible from the front side, and this line is visible from the front side, and this line is visible. Total continuous line like this. This depth line is visible at this place. You have to draw a visible line like this, dot line, and the upper line kuda ikkada manaki ee direction lo kanapadutundi. Ante total ga oka rectangular box la kanapadutundi. Clear? In which these two are edges, vertical edges in that view. Okay, and also this surface is visible surface. You have to draw these surfaces in the front view box. Clear? So start the diagram. Draw the horizontal line, which is dark line, from this corner to this corner, which is length is 75 mm. And from this one vertical line, it is height of 12 mm. From this height of 12 mm, draw 12 mm dark line from this corner. And on this corner, draw the 12 mm plus 25. Total height is 37. Draw the 37 height, because here this is the dark line, and this point is coincide. This line is visible at this place. Total 37 height is vertical line. Okay. Next, draw this line. This is line is also dark line from this corner to this corner, and this line is visible, and this line is visible. So this is the total horizontal line, in which 2 edges, vertical edges are there, groove edges. This is the groove edges, vertical line, 25 mm from each side. From this 25 and from this 25. From each side, 25 mm, draw the 2 vertical lines. Okay, this bottom surface is visible like this. Yeah, visible surfaces are, this is the one of the rectangle. Here, this is the rectangle. And this depth, in depth, another surface is visible in the front side. This is the visible like this here, and another surface is there. This surface is front view is visible like this rectangle. Okay, this is the 25 mm each side. Draw 2 vertical lines. Clear? After getting these 2 vertical lines, this from this corner, 20 mm width on the left side of the left side, towards the left side, draw a horizontal line, which is visible line, dot line. From this, one inclined line is there. This inclined line that ends at a distance of 20 mm from the right side. So you have to locate the point on this surface at 20 mm distance, and that join that point with this point like this. So this point we have to locate first. Locate this point at a distance of 20 mm from this side, and join this point and this point. We will get this surface. So visible surface is, this is the visible surface, and these 3 are visible surfaces from the front side. Here, like this, you have to draw the front view for this diagram. Clear? This is the front view, and remaining this line is must be a thin. First box draw chestunappudu, you have to draw the boxes with a thin pencil, thin lines, and after that you have to construct the actual front view with the dark lines. Clear? Visible surfaces, locate that visible surfaces with dark lines. Coming to the top view, draw the top view. When looking from the top side, this surface is total visible. That means this horizontal line and some vertical line, that is the depth line. and horizontal line, and coming to the outside of the depth line and horizontal line. Like this, you have to draw the top view. This is a 25 mm length, draw horizontal line 25 mm, and depth is 12 mm. This is the depth is 12 mm, draw the depth, this line length is 12 mm, and draw the horizontal line which is equal to the 25 mm length, 25 mm length, and draw again a depth line which is 12 mm equal. Then complete the diagonal horizontal line from this point to this point. Here I am drawing the top view. In the top view, the visible surface is, this one is the visible surface. You have to draw this surface, and also this surface is visible from the top side, and also this is the visible surface from the top side. Final choose 3 surfaces, visible surfaces. Okay, so already I drawn this surface up to this corner to this corner, and then draw a vertical line, completely dot line. This is the completely dot lines on 2 sides, this dot line, and this is the one dot line, and which is coincide with this point, and this is also dot line. Completely, this is the 25 mm, and this is the 25 mm. Total 50. Width is 50. Clear? So after getting these 2 lines, join those 2 lines with horizontal line from this point to this corner point is also. This horizontal line is also visible, and this horizontal line also visible from the top side. Totally, these 3 lines are visible on the same horizontal line when we're looking from the top side. Okay, this is the top. This inclined line is also looking as a reduced length line. Okay, from this 20 mm, and this inclined line is also reduced. This inclined line, inclined line is a reduced length, and this is the horizontal line from this place to this place, and remaining line is 20 mm width from this to this. Like this, you have to draw the horizontal line from the top side. So this is the visible surface from the top side. Again, you have to draw this surface and this surface. So draw that 20 mm width line. This is the 20 mm length, and draw again this line. Inclined line kuda manaki horizontal line la kanapadutundi, top side nunde reduced length kanapadutundi. So ekkada varaku draw cheyala aa line anedi ee end nundi 20 mm distance variki. Ee distance emo 20, ee distance kuda 20 mm distance variki end point, end cheyala point aa line. So after that, this line is visible line from the top side, and also this line is visible from the top side. So this is the inclined surface. This is the inclined surface number 1. This is the number 1 is the inclined surface, looks like a plane surface in the top view. And this is the second one. Second surface is visible in a rectangle surface. This is the rectangle surface. And this surface is third one. Third surface which is visible from the top side. This is the third surface. Okay. Here there is no material is there. In this, a groove is there, no material. So you have to draw this line as thin line. Okay. In thin line. Clear? This is the top. When looking this diagram from the top view surfaces are these. Next, coming to this is the top view. Coming to the side view, when we observe this diagram from the side view, left side view, this surface is a bottom rectangular surface is visible, and this inclined surface is visible as a vertical surface in the side view. Okay. And this surface is also there in the front view side, but it is invisible. That's why we have to draw this vertical line as dotted line here, because it is an invisible dark line. Clear? I'm going to draw the side view. First, to draw the horizontal line in the side view, and this is the vertical line 12 mm, and this is also inclined line. Inclined line looks like a vertical line up to 25 mm height. This is the total 37 height vertical line. On this side, only 12 mm height vertical line. Okay. And this is the horizontal line. This is the horizontal line, which is 50 mm width. This is a 25 mm width. Draw this the line, horizontal line from this 25 mm length up to 25 mm. Close it. This is a vertical line or inclined line, which looks like a vertical line in the side. Okay. So the dotted line, the dark line here, one dark line is there. This dark line and coincide with this corner, dark line which is passing through this corner, which is dotted line in this surface, because this dark line is invisible line from this side. Okay, so that is the dotted line. The dotted line which is at a distance of 12 mm from one end. This end, from this end, 12 mm depth lo dotted line draw cheyali, because ikkada 12 mm depth lo dark vertical line undi kabatti ఆ 12 mm depth లో dotted line draw చేసుకుంటాం. It is invisible line. Okay, అర్థమైందా? Again I will explain. This surface is invisible, a visible surface from the side view, and this inclined surface is also visible. This is the invisible surface, but this surface is coincide with the surface, but this dark line is not there here. You have to draw the dark line. Dark line has a dotted line. It is invisible. So this is the first surface, inclined surface, which will be vertical surface here in the side view, which will be looking as a vertical surface in the side view. This is the first surface. This is the first surface which is visible. This is the first surface, and second surface is visible. This bottom surface is visible, second surface, and this surface is third one is invisible. That's why I am drawing a dotted line here. Clear? The third surface is invisible, but it is coincide with the second surface, but dark line is invisible. The dark line is looking as a dotted line in the side. Clear? Like this, you have to draw the side view, left side view. It is called the left side view, which is on the right side of the front view. Clear? Left side view is always right side of the front view. Right side view always on the right left side of the front. Right side view left side ఉంటుంది, left side view ఏమో right side కి ఇవ్వాలి మనం. If it is a first quadrant system. Clear? After getting the three views, you have to give the dimensions. Whatever the given in the isometric diagram, you have to give the dimensions for the orthographic views. So 20 mm, this is the 20 mm you drawn from this place to this place, and the 20 mm from this place to this corner, you have to draw the 20 mm. You have to locate the dimension 20 mm. And this total height is from this place to this place is 25 mm given, height from upper surface to the topmost surface. And the height of this bottom surface is 12 mm. It is given at 12 mm, total 37 mm. Then total 75 mm length diagram in the top view. This is 75 mm. And this is 25 mm up to groove point, 25 mm. And remaining also 25, because 25, 25, 3 25 is a 75, total 75. This groove length is also 25. And 50 mm is the width. When looking from the top side, the width is 50 mm. Okay. This is also width side view. For the side view, width is visible, 50 mm. 25 mm is this length. This inclined surface width is 25 mm. And dotted line, which is at a distance of 12 mm from right end, this is 12 mm dotted line. These are the dimensions of the given isometric diagrams. You have to locate the dimensions on the orthographic views. These three views are called orthographic views: front view, top view, left side view. Clear? So you have to remember one thing. When you're drawing the front view or a side view or top view, any views, what are the surfaces which are visible in that respective side? If you know the surfaces which are visible, then you can draw the surfaces on the front view or top view or side view easily. So first of all, for the given diagram, write down the length, width, height of the diagram, and draw the three boxes sizes: front view, top view, and left side view boxes with these dimensions: length and height front view, top view is length and width, left side view, either it is left side view or right side view. For this diagram, we can draw the left side view. For some other diagrams, you can draw the right side view. Whatever the side view is possible for the given diagram, you have to draw the side view. Dimensions are width and height. Clear? You have to draw the dimensions. First, you have to take in the dimension from the given diagram and draw the 3 boxes with these dimensions. After drawing the 3 boxes, you have to insert the surfaces are visible, which were the surfaces which are visible from the respective side. You have to insert those surfaces into the boxes. Okay, clear? The surfaces which are visible from the front side, you have to insert those surfaces in the front view box. The surfaces which are visible from the top side, those surfaces must be inserted in the top view box. And the surfaces which are visible from the side view, those surfaces must be inserted into the side view box. Okay, so draw the boxes first with the given dimensions. That boxes must be thin line. Okay, the required surfaces only dark lines. Clear? Let us go for the second problem. This is the second problem. Draw side, front to side and top views for this diagram. For this diagram, the arrow mark is given in this side. So you have to take this side as a front view. The arrow mark A side lo iste, a side lo manam front view anukovali. Remaining sides, the arrow mark in A side avutundi, right side view avutundi. Okay, right side. So you have to draw the right side view for this diagram. The right side view must be left side of the front view and top view. Clear? So first of all, write down the length, width and height for this diagram. Length is, when looking from this side, this is the length. It becomes length. This becomes width and this becomes height. Okay. Length is 20, 18, 18. 36 plus 20, 56 is the 56 mm is the length. These dimensions are in mm. All the dimensions which are located in the diagram is mm. So length is total 56 length from this corner to this corner. Overall length of the diagram is 56. Overall width of the diagram is given as 32 here. From this point, the back side of the diagram is 32 is given. Here, the overall width is 32. And overall height, height is given as here 16 height is there. One wedge shaped block, 16 height from this to this. And from top surface to bottom surface, this height is given as 8 mm. This is 8 mm. Okay. Total 16 plus 8 is 24 mm. Here you have to extract the data from the given diagram like this. After extracting the length, width and height, draw the boxes with these dimensions. Front view box is always with length and height. So this is the length and height. Top view is always with the dimensions length and width, top view, and side view. This is the side view, right side view. We can draw the right side view for this diagram. Right side view is width and height. This is the width and height is visible dimension in the side. Clear? After getting the dimensions of the block, you have to draw the boxes. So whenever you draw the front view box, you have to leave the space, some space on the left side of the front view, because you have to draw the right side view. Right side view is always left side of the front view box. You have to leave some space on the left side of the box. Okay, right side view vachinappudu left side lo space vadalukondi front view box ki. Left side view vachinappudu front view box ki right side lo space vadaleyali. Okay, like this you have to plan. Draw the front view box. Front view box dimensions enti, length and height. What is the length of the diagram? 56. Height is 24. So draw the 56 length, 24 height to oka box construct cheyandi, rectangular box. 56 and 24. Next, draw the top view box. Top view box dimensions, length and width. Length is 56 mm, width is 32 mm. So length is common for these two. So draw the 56 length and 32 mm width. 56, 32 box construction. This is the top view box. Okay. Then coming to the side view, it is a right side view box. For this right side view, a right side view is the dimensions of width and height. Width is 32. This is the 32 width. And 24 is the height. Height is the common for these two diagrams. Width is common for these two diagrams. Length is common for these two diagrams. Okay? Length and height అనేది రెండిటి కామన్. అందువల్ల ఇక్కడ నుండి డ్రా చేస్తూ దీనికి ప్యారలల్ గా ఈ ఫ్రంట్ సైడ్ వ్యూ బాక్స్ ని కన్స్ట్రక్ట్ చేయాలి. Width is 32 and height is 24. Clear? Like this you have to construct 3 boxes. ఈ బాక్సెస్ కూడా ఎలా కన్స్ట్రక్ట్ చేయాలి? ఫ్రంట్ వ్యూ డ్రా చేసిన తర్వాత ఫ్రంట్ వ్యూ నుండి ఒక థిన్ లైన్ డ్రా చేసుకోవాలి. ఓకేనా? థిన్ లైన్ డ్రా చేసేసుకొని ఆ లెంత్ తో ఈ బాక్స్ కన్స్ట్రక్ట్ చేయాలి. ఫ్రంట్ వ్యూ బాక్స్ నుండి ఒక సైడ్ కి థిన్ లైన్స్ డ్రా చేసుకొని ఆ హైట్ తో విత్ 32 తో ఒక బాక్స్ కన్స్ట్రక్ట్ చేయాలి. క్లియర్? Like this, you have to construct 3 boxes for this. And visible surfaces from the front side, front view to start cheyadam. So always start the diagram with the front view. So in the front view, the visible surfaces are, ikkada nundi observe chesinappudu, visible surfaces are, this surface is visible, this inclined surface is also visible, it is reduced in length from the front side, and this surface is visible. Ilanti oka inclined surface is itu kuda untundi, adi visible, and this surface is also visible. Along with this inclined surface, vertical surface is also visible, inclined vertical surface. These surfaces are visible from the front side. You have to insert these surfaces in the front view box. Okay? And from the top view, the visible surfaces are, this is the visible surface, and from top view, this surface is also visible because it is in inclined position. And from the top view, this surface is also visible. Okay, from the side view, ikkada nundi observe chesinappudu manaki visible surface anedi idi okati visible surface, and this inclined surface also visible surface, and this surface is visible surface. Clear? These are the surfaces which are visible in different directions. So starting from the front view, blue hatching lines to start cheyandi. A total ikkada nundi ee corner nundi idi visible, ee line visible, ilanti inclined line atwaipu kuda untundi, adi visible, and horizontal visible. Total bottom line is dark. Okay, total bottom line dark chesesi. Alanti dark line ee 8 mm height lo kuda ee line visible, ee line kuda visible. This horizontal line is visible, this inclined line is visible, which is looks like a horizontal line, and this is 12 mm with the line is a horizontal line. So total from this corner to this corner is a horizontal line. Okay, and height is 8 mm on both sides. Height, this line height and this line height is 8 mm. And close it, it is a rectangular surface. It looks like a rectangular surface in which the vertical edges are there. This is the one of the vertical edge, this is another vertical edge, this is another vertical edge, and the corner, the edge which is passing through this corner is also vertical edge. These 4 vertical edges are visible in these surfaces. Okay, and draw the vertical line at the center. This is the vertical line, and this is also vertical line on other side, which is width is in between, distance between these two is 8 mm, and close it 8 mm length. That is the horizontal line. Okay, and this inclined line, this is inclined surface is visible as a vertical surface in the front, which is reduced in length. Okay, another vertical edges are, this is the vertical edge, 2 vertical edges on both sides. From this side is 12 mm, from this side 12 mm. Draw 2 vertical edges on both sides. From this side is 12 mm, from this side is 12 mm distance lo 2 vertical edges draw cheyandi. Alane another 2 vertical edges, this vertical edge is also visible. Okay, the width of that vertical edges in between these two is 20 mm. So from center line it is 10 mm on one side and 10 mm on that side. Clear? Otherwise 18 mm from this end. Draw the this vertical edge is 18 mm from this end and 18 mm from this end. 1 mm oka vertical edge emo 12 mm distance lo on both sides, oka vertical edge emo 18 mm on both sides. So in between these two the distance is 6 mm. Okay, this is the front view, the visible surfaces from the front view. Coming to the top view. Top view నుండి మనం అబ్జర్వ్ చేసినప్పుడు ఈ సర్ఫేస్ మొత్తం విజిబుల్ అండ్ దిస్ సర్ఫేస్ ఇస్ విజిబుల్. సో this is a total dark line on the back side, and this is a 16 mm width on both sides. This is a 16 on both sides, and this is the 12 mm on both sides on inside towards the inside. This is a 12 mm line, this is a 12 mm line, these are the 12 mm line, and this is the 20 mm line which is visible from the top side, 20 mm. After drawing the 20 mm, connect this point to this point and connect this point to this point, connect this point to this point and connect this point to this point. This is the top view when looking from the top side. And also the another 2 surfaces are there. this surface, and this surface is also visible from the top side. Draw the two vertical lines. This is the two vertical line length is 24 mm. This is a 24 mm length, and this is the end of the 24 this slot horizontal line. 24. This the width is 8 mm, and this is also 8 mm, which is at a distance of 14 mm from the back side. Ikkada nundi 14 mm distance lo horizontal line draw chesukondi. Okati 14 mm distance lo horizontal line, okati 24 mm distance lo horizontal line. Total line length, the two line lengths are 24. Okay. This surface is visible. Okay, here you can draw chesam. The inclined surface is visible, but it is a reduced length. This is the surface which is reduced length. A remaining surface is this one. Total this one is visible surface. Here, like this, you have to draw the top view. Coming to the side view, and looking from this diagram from this this side, this bottom line is visible line, dark line, and height is 8 mm. ఇక్కడ 8 mm draw చేసుకుంటాం, ఇక్కడ కూడా 8 mm draw చేసుకుంటాం. And this upper line is also dark line. ఈ మొత్తం లైన్ కూడా హారిజాంటల్ లైన్ లా కనబడుతుంది మనకి, ఎందుకంటే ఇక్కడ నుండి డార్క్ లైన్ హారిజాంటల్ లైన్, ఈ పాయింట్ కోయిన్సైడ్ అవుతుంది సైడ్ వ్యూలో. ఇది ఇంక్లైన్ లైన్ కూడా సైడ్ వ్యూలో మనకి ఇలా కనబడుతుంది. సైడ్ వ్యూలో ఇది ఇక్కడికి వచ్చేసి ఇలా కనబడుతుంది ఈ సర్ఫేస్, reduced length surface. Okay, you have to draw this diagram in this side view. Clear? Then this edge, this vertical edge is at a distance of 16 mm from this side or this side. Total 32. Center lo vertical edge draw cheyali 32. Okay. This is the bottom surface, visible surfaces. Coming to the upper wedge shaped block is there. This surface is visible surface. So from this corner is coincide అవుతుంది. ఇక్కడ నుండి 16 mm distance లో vertical line. So vertical line 16 mm length, and this length is 14 mm. Draw 14 mm line inside towards the inside, 14 mm length, and this inclined line, which is this point is located at a distance of 24 from the back side of the diagram. అంటే ఇక్కడ నుండి 24 mm distance లో ఒక పాయింట్ లొకేట్ చేసుకొని ఆ పాయింట్ ని ఈ పాయింట్ ని జాయిన్ చేసుకుంటాం. ఇక్కడ నుండి 24 mm distance లో ఒక పాయింట్ లొకేట్ చేసుకొని ఆ పాయింట్ ని ఈ మనకి ఫామ్ అయిన పాయింట్ ని జాయిన్ చేసుకుంటే ఈ ఇంక్లైన్ లైన్ వచ్చేస్తుంది. ఓకే, this is a visible surface. Like this, you have to draw the front view, top view, and side view. There is no dotted lines in this diagram. All are visible lines only. Another invisible lines are there, but those invisible lines are coincide with the visible lines. That's why you are not drawing any dotted lines here. So front view, top view. What type of side view it is? Right side view, which is left side of the front view. ఎందుకు లెఫ్ట్ సైడ్ డ్రా చేస్తున్నాం రైట్ సైడ్ వ్యూ అంటే, మనం ఇక్కడ నుండి అబ్జర్వ్ చేసినప్పుడు ఇది ఫ్రంట్ వ్యూ అవుతుంది. ఫ్రంట్ వ్యూకి రైట్ సైడ్ లోనే ఈ డయాగ్రామ్ ని మనం అబ్జర్వ్ చేయగలం. ఇక్కడ నుండి మనం అబ్జర్వ్ చేయలేం కాబట్టి రైట్ సైడ్ నుండి అబ్జర్వ్ చేయగలం కాబట్టి హౌ టు డ్రా ద రైట్ సైడ్ వ్యూ ఫస్ట్ ఆఫ్ ఆల్. సో ఇన్ ఫస్ట్ యాంగిల్ ప్రొజెక్షన్ రైట్ సైడ్ వ్యూ ఇస్ ఆల్వేస్ లెఫ్ట్ సైడ్ ఆఫ్ ద ఫ్రంట్ వ్యూ. ఓకే, ఇక్కడ నుండి డ్రా చేసినప్పుడు ఇట్ విల్ బి ప్రొజెక్టెడ్ ఆన్ టు దిస్ సైడ్. ఈ సైడ్ లో ప్రొజెక్ట్ అవుతుంది లెఫ్ట్ సైడ్. క్లియర్? సో గివ్ ద డైమెన్షన్స్ ఫర్ దిస్. 12 mm. This vertical edge on one side is 12 mm. This is also vertical edge from one side is 12 mm. This total 24 from way to way 24. This dimension is 24 from this side. 24 is the width, 24, and this the width is 8 mm. Width of this vertical this inclined wedge is 8 mm. 16 mm height, and 8 mm also height is there. Total 24 height is, and 18 mm from this 18 mm from the 18 mm draw the vertical line. This is from this point to this point is 18 mm, and also 18 mm on the other side. In between those two 20 mm length is there, and 16 mm. This is a 16 mm from this point to this point. Otherwise, this point to this point is also 16 mm. Total 32 width. 32 width is the inside view. 32 width when looking from this side, this is 32, and this vertical line from one side is 16, and 24 from one side, from back side of the diagram. This is the 24. This point is located at 24 at distance, And this is a 14 distance. 14, like this, you have to give the dimensions, whatever contained in the isometric view, how to give the dimensions like this. Okay, these are the dimensions which are located in the orthographic views. These are called the orthographic views: front view, top view, side view, and this is the isometric view. We are converting this isometric view into all these three views. Clear? This is the second problem. And let us go for the third problem. Draw the front view, top view, and side view for the following isometric diagram. First, write down the dimensions of this diagram. Length 84. This is the arrow mark represent here. It is inbuilt arrow mark which is given in the diagram. Diagram itself, the arrow mark ఇచ్చేస్తాడు. ఈ arrow mark ఉన్న చోటు నుండి చూస్తే ఫ్రంట్ వ్యూ అనుకుంటాం. ఓకే, ఫ్రంట్ వ్యూ డైమెన్షన్స్ లో ఉండేది ఈ డైరెక్షన్ లో ఉండేది ఈ arrow mark కి పర్పెండిక్యులర్ గా ఉండేది లెంత్. ఈ arrow mark డైరెక్షన్ లోనే ఉండేది విడ్త్. ఓకే, ఈ arrow mark కి పర్పెండిక్యులర్ గా అప్పర్ సైడ్ ఉండేది హైట్. ఓకే, so length of this diagram is 84. L is 84. Width, how much width is given for this diagram? It is given here 42. 42 is the width, and height is total height is also 42. Okay, 84 length, 42 width, and 42 height. Draw the three boxes with the dimensions. Front view box with the length and height 84 and 42. Top view box is also 84 with width and here 42, 84, 42. And for this diagram, we can draw the left side, because for arrow marks, from the arrow mark, we can see this diagram from the left side. So left side view, from the left side view, the visible dimensions are width and height, that is a 42, 42. So it is a square. Side view dimension box is square. First to draw the front view box with the dimensions for 84 and 42. Draw the 84 line, 42 line. 84, 42 తో కన్స్ట్రక్ట్ చేసుకుంటే ఒక బాక్స్ థిన్ లైన్స్ ఇవి థిన్ గా ఉండాలి. దెన్ డ్రా ద బాక్స్ టాప్ వ్యూ బాక్స్ విచ్ ఇస్ ఆల్సో లెంత్ 84 అండ్ విడ్త్ ఈస్ 42. ఇక్కడ విడ్త్ హైట్ రెండు సేమే కాబట్టి రెండు సేమ్ బాక్సెస్ వస్తాయి. కమింగ్ టు ద సైడ్ వ్యూ బాక్స్ డైమెన్షన్స్ 42, 42. 42 width, 42 height. Okay. The side view here, left side view on the right side of the front view. The right side of space will choose. You have to draw the left side view on the right side of the front view box. First, construct these three boxes from the given dimensions. After getting the boxes, you have to draw the surfaces, insert the surfaces which are visible from the respective sides into these boxes. The sides which are visible from the front side are inserted in the front view box. The surfaces which are visible from the top side, which are inserted in the top view box, and the surfaces which are visible from the left side, the surfaces must be inserted in the side view box. Okay, let us start. The horizontal line in the front view box, because this is the visible line, dark line, and the height of the diagram, this is the small height of the diagram, bottom diagram is 12 mm. Draw the 12 mm length, vertical lines on either side, and draw the horizontal line from the both sides. This from this point to this point, this point to this point. How much distance it is? 12 mm. From one side 12 mm, another side is good 12 mm. You can only 12 mm distance variki. You can only 12 mm distance variki draw cheskuntam lines ni. Okay. Next, from the center, draw. This is total width is 36. From the center of the box, draw the horizontal line at the top, that is 18 mm on one side, 18 mm on another side. Like that, you have to draw the total 36 mm length from the center, 18 mm on both sides. After getting these 2 points, join these 2 points with these 2 points. Like this, you have to join these 2 points. These are the inclined when looking from the front side. Okay. After getting this surface, invisible surface, draw the circle. This is the circle having the diameter 20 mm here given 520. So locate that center point for that circle. How to locate the center point? Draw horizontal axis line. This is the draw the horizontal axis line at a distance of 15 mm from the top surface. This is a 15 mm given. Okay, and from one end of the diagram, 42 at a distance of 42 for the vertical line, vertical axis line, which is at a distance of 42 from the one end. Those two intersect with each other. The intersecting point is itself in the center of the circle. Okay, these are the circular holes. Circular holes are there. Draw the circle. This circle diameter must be 20 mm diameter. Okay, or 10 mm radius. So with this center point, take a compass with a 10 mm radius, draw a circle. Okay, and another dotted line is there here. Which one is the invisible line here? This line is there, no? This line from this point to this point, this is visible, invisible from the front side. At this point, this is must be drawn with the dotted line. Okay, that is invisible line. When looking from the front side, this line, the line which is passing through this corner is invisible. So that's why I'm drawing a dotted line here, invisible line. Clear? Coming to the top view, I draw the top view. When looking from the top side, this is horizontal line, this is a line. This line is also visible on both sides, and this total line is looks like a horizontal line, and this total line is looks like a horizontal line. That's why construct a rectangle shape and draw a vertical line, vertical axis lines at the center of the diagram. And this is the width. These two wedges are there. From this side, it is a 15 mm width. From this side, 15 mm distance lo okati draw cheskondi. Horizontal line. The horizontal line length ఎంత ఉండాలి? Total length ఇక్కడ నుండి 12 mm వరకు, అంటే ఇక్కడ నుండి ఇక్కడ నుండి ఒక స్మాల్ థిన్ వర్టికల్ లైన్ డ్రా చేసుకుంటే, ఇక్కడ నుండి స్మాల్ థిన్ వర్టికల్ లైన్ డ్రా చేసుకుంటే, ఇక్కడ నుండి 15 mm డిస్టెన్స్ లో ఒక హారిజంటల్ లైన్ ఇక్కడ నుండి ఇక్కడ వరకు డ్రా చేసుకోవాలి. క్లియర్? సో ఆఫ్టర్ గెటింగ్ దట్ లైన్, draw another parallel line which is also at a distance of 15 mm from this side, and length of this is, how much length it is? 12 total 24, 84 minus this 12 total 24, 84 minus 24 is 60. So line length is 60. These two lines length are 60 at a distance of 15 mm from both sides. Then the visible surface in this diagram is from the top side. So this is a visible surface from the top side. This is a visible surface from the top side, and also this is visible from the top side. This is also visible surface. Plant రెండు కూడా ఇటువైపు ఉంటాయి, అవి కూడా visible, and the bottom surface ఇదంతా visible surface. ఇదంతా visible surface. So ఈ లైన్స్ మనం డ్రా చేస్తున్నాం. ఇక్కడ నుండి ఇది 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 అంతా horizontal line. And ఈ వెడ్జ్ ఉన్నాయి చూడండి, ఈ డాటెడ్ లైన్, ఈ డార్క్ లైన్స్, ఈ డార్క్ లైన్, ఈ డార్క్ లైన్ విజిబుల్ డార్క్ లైన్స్. ఇది కూడా డార్క్ లైన్, ఇది డార్క్ లైన్, ఇటువైపు కూడా ఈ డార్క్ లైన్, అలాంటి లైన్ ఇక్కడ కూడా ఉంటుంది. అలాంటి టూ డార్క్ లైన్స్ డ్రా చేసేసుకోండి. ఓకే, ఆన్ బోత్ సైడ్స్ రెండు వైపులా ఒకేలాగా ఉన్నాయి కాబట్టి డ్రా ద టూ వర్టికల్ లైన్స్, దట్ ఈస్ ద డార్క్ లైన్స్. ఈ డార్క్ లైన్ ఏమో ఇక్కడ నుండి 12 mm డిస్టెన్స్ లో, ఈ డార్క్ లైన్ ఏమో ఈ సెంటర్ నుండి 18 mm డిస్టెన్స్. ఇటువైపు కూడా అంతే, 18 mm ఒకటి, ఇటువైపు నుండి 12 mm డిస్టెన్స్. డ్రా టూ డాటెడ్ లైన్స్. ఈ డాటెడ్ లైన్స్ రిప్రజెంట్ ఏం చేస్తారంటే, ఈ సర్ఫేస్ లో ఈ హోల్ పై నుండి చూసినప్పుడు కనబడదు. సో దిస్ హోల్ ఈజ్ ఇన్విజిబుల్ ఫ్రమ్ ద టాప్ సైడ్. ద హోల్ డయామీటర్ ఈజ్ 20 mm. సో ఫ్రమ్ ద యాక్సిస్ ఇటువైపు 10 mm, ఇటువైపు 10 mm డిస్టెన్స్ లో horizontal lines, dotted lines వస్తాయి. ఈ హోల్ అనేది టాప్ సైడ్ నుండి విజిబుల్ కాబట్టి దట్ హోల్ ఈజ్ ఇన్విజిబుల్ dotted lines on both sides. రెండు వైపులా హోల్స్ ఉన్నాయి. సో యూ హావ్ టు డ్రా ద dotted lines. ఈ యాక్సిస్ లైన్ నుండి రెండు వైపులా 10 mm డిస్టెన్స్ లో సెంటర్ లైన్ నుండి రెండు వైపులా dotted lines డ్రా చేయాలి. ఓకే, కమింగ్ టు ద సైడ్ వ్యూ, ఇక్కడ నుండి అబ్జర్వ్ చేసినప్పుడు ఈ horizontal line, these two vertical lines, and this is a horizontal line. So this rectangular surface is visible surface in the side view, and this is a vertical, this is the incline is there, but it is looks like a vertical in the side view on both sides, and the width is 15 mm from both sides, and close this line up to this top surface. This is the inclined line, but it looks like a vertical line in this side view. And draw the horizontal axis line. This is the axis line. One long and short leg is the axis lines in both sides, which is at a distance of 15 mm from the top side. Top surface నుండి 15 mm distance లో ఈ axis line draw చేసుకుంటాం. Axis line ki both sides రెండు వైపులా 10 mm distance లో dotted line, because this hole is invisible in the side view also. On both sides, two holes are there in two vertical edges. In these two vertical edges, two holes are invisible. That's why I'm drawing a dotted line on both sides. This is the axis line. This is the dotted line. Dotted line represents invisible lines. Hole is invisible from the side view. Okay. So give the dimensions after getting the front view, top view, and side view. 84 is the total length. 36 is the length. The top surface length is 36. And 12 from this point to this point is 12 is given here. And diameter of this hole is 520. Diameter is 20. And this circle horizontal axis is at a distance of 15 mm from top surface, which is given here. And 84 is the length of the top view. 42 is the width of the top view. And also width of the side view is also 42. 15 mm, this is a wedge shaped, is 15 mm on both sides. Two are there like that. And 42 is the height. 12 mm is the height of this bottom surface. 12 mm, this is the bottom surface height is 12 mm. This is the front view, top view, and left side. Okay, this is the left side view, which is on right side of the front. Clear? Like this, you have to draw any diagram. You can convert the isometric view into orthographic views. These are the orthographic views. Fourth diagram, fifth problem, I will explain in the next class. I will close this class at this time. So practice some more problems which is given in the question bank and ask the doubts. Okay, bye. Have a nice day, students.